we better stipulate that b is greater than or equal to 2. We're doing a modular arithmetic problem tonight, folks. And if b was equal to 1, mod 1 is not very interesting, okay? So everything's congruent to everything mod 1. So we're going to stipulate that b is a natural number, a positive integer greater than or equal to 2. Now, something to write down here that's useful, I think. X congruent to 1 modulo a raised to the b is equivalent to saying x minus 1 is some multiple. We'll call it m. And m, and I'll just go ahead and use parentheses here. Like that, okay? So x congruent to 1 modulo a raised to b is equivalent to saying a raised to the b is a divisor of x minus 1, or you can write it like this also. Now we're trying to prove in this circumstance that x raised to the a would be congruent to 1 modulo a to the b plus 1. So they're kind of look-alike here. You know, you just raise the modulus up by an extra power of a, all right? Now, so again, we want to show that a to the b plus 1 divides x to the a minus 1, which is why we consider this very well-known algebraic identity. You can check that this works out. Everything magically cancels out except the x to the a term and the minus 1 term. It's sometimes, I guess, called telescoping expansion. Okay, let's keep going. It's really a fairly straightforward proof, and we'll work a concrete example when we're done here. Just as I mentioned, the given implies that x minus 1 is a multiple of a raised to the b, and so that's what we do. We just replace x to the minus 1 with m times a to the b, all right? Now, the other thing that's useful to notice right here also, just from this given, this would also tell us that x is congruent to 1 just modulo a, mod a. And that's simply because a is a divisor of a to the b, right? So you see how we can drop the b here? A to the b certainly contains a as a divisor. So x would have to be congruent to 1 modulo a based on this given condition, which we also got this mileage out of that also, okay? So anyway, that turned out to be quite useful. X congruent to 1 mod a means we can replace all of these x's with 1, you see? But notice that there are exactly a terms here, okay? Let me write this carefully right underneath. There are a, that's an a, folks, kind of a warped looking a, but there are a terms here. And that should be pretty clear if you look at just the superscripting. Look, you have 1 all the way up to a minus 1. That would be a minus 1 terms. And then if you count the 1, that's why we have a terms in this expansion. So you see, we can write this now as m times a to the b. And this is a1's in here, right? So this is times a. So folks, you see this is equivalent. So we have x to the a minus 1 is equal to ab times a, but that is equal to m a to the b plus 1, right? Isn't that cool? Okay, so again, there's an understood 1 right here, right? So that's equivalent to saying is x to the a minus 1. Well, wait a minute. Let's just go ahead and write it in the congruence fashion. X to the a minus x to the a is congruent to 1 modulo a to the b plus 1. Okay, so again, this statement right here that you see, x to the a minus 1 is 100% equivalent to writing it this way. Because you could think of this as subtract 1 from both sides and you get x to the a minus 1 is some multiple of a to the b plus 1, which is what this says right up here. So kind of neat stuff. Our given just gave us one more piece of information. I didn't figure this out very quickly because I didn't realize you could use this given twice. You can use the given to write this statement. You can use the given to write this statement. And that's simply because a is always a divisor of a raised to the b power. Very simple there. Okay, so now let's go ahead and take a look at a concrete example here. Let's go ahead and pick some simple calculations here. You can pick, let's pick a equals 2. So just so we can do these in our heads. A equals 2 and b, sorry, we need to write this as a equals 2. Yeah, I'm just picking small constants, and b equals 3. Now, so folks, this would give us x is congruent to 1 mod 8, right? 2 cubed is 8. 2 cubed is 8, so we'll do mod 8. All right, now let's go ahead and choose. We can go ahead and pick x equals to 9 if you want, just a simple example. X equals to 9, 9 minus 1 is certainly divisible by 8. It's equal to 8. So we can pick x equals 9. We could also pick x equals 17. All right, but what happens here, so we have x equals 9. So right here, this would become 9 squared is congruent to 1. Now this time it's going to be mod a to the b plus 1. So that will be mod 16 by our choices here, right? But that's certainly the case, folks, because 9 squared minus 1 is 80. So 80 equals to 5 times 16, right? 80 equals to 5 times 16. So you kind of believe that there's one numerical example. It also would work out quickly for 17. You would get 17 squared is 289 minus 1 is 288, and 288 is equal to 16 times 18, I believe. But in any event, this is a concrete example. But this part right here is the proof, so I should write QED, I guess. Okay, we proved what we set out to prove. Thank you for viewing.